section 1, our essential questions are, remember, you don't have to write this. Number 1, what are the SI base units for time, length, mass, and temperature? How does adding a prefix change a unit? And how are the derived units different for volume and density? First of all, we got some base units here.
You got it right here.
I'm about to give you the definitions. SI is a French word. It's a French word. It means System International. It also means Sports Illustrated. Système International. It's a French word. It's French for international system. Same thing. So basically, we have an international system of measurements so that we're all on the same page. If some of us are talking about inches and some of us are talking about centimeters, then we'll have a problem. So we have an international system, or the French word Système International, to keep everything the same. So let's start with time. What is our official SI unit for time? So we're not talking about time zone, we're talking about the unit. Minutes? What else?
Seconds.
Seconds. I like seconds better. We're going to measure time in seconds. And we abbreviate that with a lowercase s. How about length? I'm hearing centimeters, meters, yards. Inches are what we use in the U.S. We don't, but that's not really right. Meters. Meter is the official measurement for length. How about mass? Gram. I'm hearing gram. It's close. Put a prefix in front of that gram. What kind of gram? Not a milligram. Kilogram. Mass is the only base unit that has a prefix. Kilogram. Everything else is just straight up. Temperature. This one's tricky. I'm hearing Celsius, Fahrenheit. It's neither of those. We got an even better one. Starts with a K. Kelvin.
Whoa.
Nailed it. Extra credit right there. Kelvin, it's abbreviated with a K. Or I forgot these other ones. Meter is M. Kilogram is kg. And amount, this one, I wasn't going to do it today, but just so you know, just to get it in your head, the unit for amount is called a mole, just like the animal. Abbreviated MOL. It's kind of a funny abbreviation because it's almost a whole word, but it's just how they do it. All right. Let's talk about just some basic conversions here. A lot of people have never really seen Kelvin before. They kind of wonder what it's all about. Celsius is a little bit more familiar. Celsius was invented by a guy who really liked water. So he was like, all right, 0 degrees is going to be the freezing point of water.
What's his name?
Mr. Celsius. And 100 degrees is going to be the boiling point of water. Yeah. But then they realized there's more stuff than just water. So Mr. Kelvin came along. Actually, his name was Lord Kelvin. He was a lord. Lord Kelvin said, no. We can get a lot colder than that. So in order to go from Celsius to Kelvin, you take the Celsius, you add 273, and then you get Kelvin. And 0 degrees Kelvin is absolute zero. You cannot get colder than that in the entire universe. So Lord Kelvin decided that the scale needs to be universal, not just based on water. That's why there's such a big difference. Okay? Any questions?
So boiling point, that's like 373 Kelvin?
Boiling point of water? Yeah, it's 373 Kelvin, exactly. And the freezing point is 273. Derived units. We have some units that are not base units, units that we have to figure out ourselves. For example, volume. Volume is not an SI measurement because we need to figure it out. For example, if you want to take the volume of like a cube, you got to do length times width times height. This is of like a cube or something. Or if you had a beaker full of water, you could find the volume based on by putting it, by just looking at the measurements on your beaker. So these are derived units because you can figure it out by doing some math. The derived unit we're going to focus on today is called density. It's an intrinsic property of all matter, and it is the mass divided by the volume. It's a measurement of how much stuff you have. You could have a rock that has the same density. His name's Pedro, yeah. That has the same density as a styrofoam block. Because it's a ratio. So if the rock is really massive and the styrofoam is really light, they could have the same density because it's the ratio of the mass to the volume. Okay, can I switch it? Okay, here we go. I'm going to do a little practice problem here to find the density. So we're trying to find density here. We know that density is equal to mass divided by volume. Yeah. You don't have to write the whole problem, you can just write the work. Well, look, we got it gives us the density. It says what is the volume, so we don't know that. And it says the mass is 19.2 grams. So density is going to be 4.8. That's given. The volume we don't know. It's not given. And the mass is also given. The mass is 19.2 grams. This is grams per milliliter. So how do we solve it? Well, let's plug it into our formula. Density equals mass divided by volume. So 4.8 equals 19.2 divided by our volume, which we don't know. So that's a variable. So what do we got to do? Gavin is absolutely right. We can pretend like this is 4.8 divided by 1, and then we can cross multiply. Anytime you have a fraction equals a fraction, you cross multiply. So 4.8 times the volume equals 19.2. Divide both sides by 4.8. So if you do 19.2 divided by 4.8, you will get your answer. All right. Here we go. Moving on. Now, these are some Jolly Rancher questions.
Get it. Why?
Oh, the answer to that question.
I'll give you a hint. We got the mass.
We got the answer to the question. The volume is 4, okay? Yeah.
We got the volume. And it's saying, what is the density?
Whoa, crazy.
You don't even have to work it out, right? I calculated. Okay. The volume 0.8. Get my dollar.
Yeah, it's 0.81, so I kind of scratched it out there. We got one answer, we got two answers.
Wait.
3.
How do I do this?
You take the mass and divide it by the volume.
That's it?
Uh-huh.
I got it. I had it first.
Wait, don't go yet. You gotta give everybody a chance. My dad did a lot of things in this.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got lots of answers here.
That's right.
Yep.
So like that. Because that's the 8 behind us.
So it'd be around to 19.4 or 3.8. It wouldn't be 4. You can't. You rounded. Well.
Well, I'm gonna put 19.8.
Okay. All right. I saw Burton's hand first, but he's not paying attention. So we're going to go to Chelsea. D. Correct. There it is. Question number 2. In the SI system, how many measurements are there? I didn't tell you. This is a trick question. Blank units. There are 7 blank units. Gavin, what you think? I'll take another answer.
What did he say? He said metric.
Yes.
C?
C.
No.
Colin? D. Base. There are 7 base units. The base unit is meter, kilogram, Kelvin, all that stuff. We didn't do all 7. We just did like 4, 5. Which of the following is not paired with the correct base unit? I think I saw Walter first. What should it be, Walter? It should be kilogram. What scale provides the base unit for temperature in the SI system? I got to go back to this side. Yes, TJ. Kelvin is temperature, yes. Very good. I think I got one more, huh? I called on you, but you weren't paying attention. I'm going all the way back. Let's give Austin a chance. What you think? No, behind you. Austin. D. And how'd you get that?
You didn't give Walter his candy.
I didn't?
You gave it to somebody else.
And I need one for Austin too. Austin.
I'm ready.